Alright guys, I'm going to finish up the section 3.3 notes, so more stuff with radians. This is the last video of the chapter. I'm just going to kind of go a little bit more advanced into some of the stuff we talked about in class over the last couple days. So I'm going to start with this very first example here, and I'm on the second to last page of the notes packet, about halfway down. This says, without a calculator, decide whether each function is positive or negative. So what we need to remember, first of all, is the all students take calculus thing. The fact that in our quadrants, all of the functions are positive in the first quadrant, the sine function as well as the cosecant function are positive in the second quadrant, tangent and cotangent are positive in the third quadrant, and cosine and secant are positive in the fourth quadrant. The other thing that you guys need to remember is the decimal equivalence of the radians. So remember how up here is pi over 2, which is roughly 1.57. So the decimal is what you're going to want to remember in order to be able to tell where the function values are positive or negative in what quadrants. And you know that pi here is 3.14 rounded. And you know that 3 pi over 2, we wrote this down in class, but it's 4.71-ish. And then the 2 pi is 6.28. That's 2 pi. So what we're going to be wanting to think about here is these decimals. And so that is going to help us figure out whether the cosine of 2 is positive or negative. So think about where 2 radians would fall. So in this quadrant, or at 90 degrees, it's 1.57 radians. But at 180 degrees, or pi, it's 3.14. So 2... the integer 2 is somewhere in the second quadrant. And in the second quadrant, the cosine is negative. And that's because this is in quadrant 2. So that's how we're going to be thinking about these problems. Let's try a couple more. The sine of -1. So remember, -1 radian actually goes this way instead of this way. So start on 0 and move down 1 radian backwards. And that is, so obviously these numbers all get switched when you're moving backwards, but backwards -1 radian, that's in quadrant 4 actually. +1 radian is up here, -1 radian is down here. And in quadrant 4, the sine value is negative. So I'm going to write Q4, the sine is negative. And then last one for this section, tangent of 6.29. Okay, so be careful about 6.29. We have this labeled as 6.28, so this is just barely past one entire circle. So still in quadrant 1 is what we're talking about here. This is quadrant 1, and everything is positive in quadrant 1, including tangent. Okay, so now we're going to get into something a little bit harder. Find the value of S in the interval that makes each statement true. So these are calculator problems. So for sure have your calculator ready, and since we're going to be using the tangent, the cosine, and the sine and cotangent, whatever, all those trig buttons in the calculator, we need to be in radian mode. Here's another huge hint. If this said 0 to 360, that would mean degree mode, but here this is in radians, and so that is another hint to be in radian mode. So this means I'm going to have 2 answers. And what I'm going to type in my calculator for this one in order to get S by itself is the inverse tangent of 0.2126. And make sure that you are in radian mode when you are typing this into the calculator, but this should give you S equals 0.2095. So here's where like the hard part comes into play. So we have to think about radians in terms of decimals, like we've been doing. So this is 0 or 2 pi, which is 6.28. Pi over 2 is 1.57. Pi is 3.14. You all know that one. And then 3 pi over 2, 4.71 roughly. These are all rounded decimals. But you have to first picture where is 0.2095 and where is my second answer going to be. So the tangent is positive, you guys, in quadrant 1 as well as quadrant 3. So that's where my 2 answers are going to come from. And this answer is in quadrant 1 because it's definitely between 0 and 1.57. So I'm going to draw it. It looks like this. and my degree here, or my radian amount here is 0.2095. So the hard part is, how do I reflect that into the third quadrant? So this reference angle has to be the same as this one. So this is still 0.2095, but to write my answer between 0 and 2 pi, I need to know how many radians it is from here to here. And so it's just like what we did for degrees. In the degrees, we took the 180, which was right here, and added this reference angle. In this case, we're just using radians. So we're taking 3.14 and adding this reference angle. And that's going to give us the entire half circle plus a little bit more. So I'll do it off to the side just so you can make a little note about it, but I'm doing 3.14, or pi if you just want to use the pi button in the calculator, and I'm adding that reference angle of 2095 radians, and that is going to give me my second answer, which is 3.351. So I have two different answers over here, 0.2095 and 3.351. Let's do a couple more because I know this is a challenging type of thing. The picture is going to be your best friend here to try and help you figure out how to write your two answers. Okay? So now we've got a cosine one. So what I'm typing in the calculator, again, make sure you're in radian mode, excuse me. You're using cos inverse, 0.7826, and that gives you an angle of 0.6720 radians. Hopefully you're actually typing this with me so that you're becoming more comfortable with your calculator, that you know how to type the stuff. I've been getting a lot of questions on how do I type this, how do I type this. If you're having trouble with it, see me in class for sure before the quiz, before the test, so you can be confident that you're getting the right answers here. Where is the cosine positive? So that is in quadrant 1 as well as quadrant 4. Okay, so again, I'm going to draw this picture like I did for the last one. This is 0 or 6.28 all the way around the circle. This is 1.57, this is pi, and this is 4.71. So first of all, I have to picture where is 0.6720. Again, that's between 0 and 1.57. It's a little bit less than halfway between, so I'm going to draw my angle here. And this is how I drew it. 0.6720 goes there. And so quadrant 4 is the other location where the cosine is positive, so I need to reflect this thing down into quadrant 4. And this angle is the same as the reference angle, 0.6720. And so how do I come up with my second answer for that one? Well, again, what I'm going to do is I'm going to start my circle here, and I'm going to go all the way around, and I'm going to do almost a whole circle, aka almost 2 pi, almost 6.28, but I'm going to stop a little bit short at 0.6720. So what you're doing here is 6.28 minus 0.6720. Or you could think of that as 2 pi minus 0.6720, and it gives you 5.6112. Make sure you're typing that with me, but that's my other answer for this, 5.6112. Okay, so you have to do the reflection, and then what I would do in order to keep everything lined up and nice and organized is to label where your reference angles are. Those angles have to match, and that helps you figure out, okay, if I start here and go all the way around, it's 0.6720. Some of you might be wondering, why did I not use the 4.71 to do my addition or subtraction or whatever? We always use the x-axis in order to add or subtract. So the 0.6720 is actually not between here and here. That is incorrect math, so that's why I didn't use the 4.71. Use the 6.28 and subtract this angle, and that gives you the blue all the way around, almost the full circle, but not quite. All right, let's do this last one. This last one is a cotangent one, and I know a lot of us were getting a little bit confused with how to type a reciprocal function into the calculator. When do you do the 1 over thing? So my advice would be to rewrite this using reciprocal functions. Make it tangent of s equals 1 over 0.2994. That's the identity, is that the cotangent of theta is the tangent of 1 over that. And so what we're going to do is I'm actually going to type s equals inverse tan, and that's where the fraction comes into play, 0.2994. And that gives me S equals, when you type it in the calculator, 1.2799. And again, where is the tangent and the cotangent positive? That's quadrant 1 as well as quadrant 3. So when I draw my picture, that's what's going to help me visualize how to get my two different answers. 0 or 6.28, again 1.57, 3.14, and 4.71. So 1.2799 is like this. And that's here, 1.2799. And I need to reflect that into the third quadrant, so like this. And the reference angles have to match. Remember, you always draw your reference angle up to the x-axis or down to the x-axis. And so hopefully that helps you figure out how do I label my blue angle. The 1.2799 is one of my answers, but the blue angle is going to be 3.14 plus 1.2799, so it's a half a circle, or pi, and then plus that reference angle of 1.2799. So when we add those two numbers together, we end up with 4.4215. If you missed that, it was 3.14 plus 1.2799. Okay, and those are my two answers for that. Those are definitely some challenging problems because we haven't done that many like this yet. I'm going to move on to the next section, and if you have questions on that, star it. Let's talk about it in class tomorrow. So here's the last section I'm going to cover on the video, and these are kind of like those inverse questions that we do without the calculator. So make a note that this would be a no calculator section because these are just unit circle questions. And so what you have to decide is, first of all, what does this mean? This tells you what quadrant you're in. So between pi over 2 and pi, this is quadrant 2. So what I need to do, and I'm going to visualize here, is a triangle in quadrant 2. And remember that sine is y over r. So what is the triangle with the y value of 1/2? So the y value is the short side of 1/2. And so what that triangle looks like is this. 1/2 negative radical 3 over 2, 1. And I have to figure out what the theta is. And so you know that this is our 30-degree reference angle, but what it wants to know is what are the radians. And so what we're going to think about here is I need to figure out, okay, I know it's 150 degrees because this is a 30-degree reference angle, so 30 degrees less than 180. But if you can picture that and you get completely lost, you can know how to convert degrees to radians. But let's think about this. If it is a 30-degree reference angle, then that means that my fraction is going to be over 6. And I know it has a pi in it, so I need to figure out what that stupid top number is. And remember that this right here is pi, which is 180, all the way around the circle. And so if I know this is pi, then what is a little bit less than pi, but it has to be over 6? 1 less than 6 is 5. Okay, you can check your unit circles on that, but remember that the reference angle of 45 degrees has a denominator of 4, and the reference angle that has a 60 degrees is over 3. And so I knew what the denominator was going to be based on the reference angle, and I knew it had to have a pi in it, so I just had to come up with the top number. Well, all of the numerators that had a 1 in it were in the first quadrant. So I know it's not a 1, and 2 over 6 reduces, so it can't be that. 3 over 6 also reduces, so it can't be that. 4 over 6 reduces, so I knew it had to be 5. It's something a little bit less than 6 pi over 6, which would just be regular pi. Okay, so that is like the thought process maybe behind trying to figure these out. Let's do this last one and see if that makes it a little bit easier. This tells us right here that I am in the, what's between pi and 3 pi over 2? That would be quadrant 3. Okay, so I'm going to draw something in quadrant 3, and the tangent of S is radical 3. So those tangent ones are a little bit harder, but remember our two different tangents are either radical 3 or radical 3 over 3. And you should hopefully know by now that this is the 30, 60, 90 degree triangle. And so what I have to figure out is this is actually my bigger tangent value, meaning it's bigger than radical 3 over 3. That's the smaller one. So I have the bigger reference angle here, which is the 60 degree reference angle. So this is negative 1/2, this is negative radical 3 over 2, this is 1. This is the triangle that you're picturing. And again, I knew it was radical 3 because it was my bigger reference angle, and as theta increases, my tangent function values increase. So this is the theta that I'm trying to figure out, and I know it's in the third quadrant, and I know since it is a 60-degree reference angle, this theta right here is 60 degrees. I know my denominator is going to be over 3, and I also know there's a pi. Okay, so what I have to figure out is what is the top number value. And again, remember that this is 1 pi right here. So 3 pi over 3, if you will. The 3's would cancel at just pi. So I need something a little bit bigger than 3 to go on top because I have gone past the whole pi. So 4 pi over 3. In case you were wondering or getting confused, 5 pi over 3 is in the fourth quadrant. And then 6 pi over 3 is 2 pi. So that takes you all the way around the circle. Okay, so this is something that you probably had to look up. If you needed to, you could figure out that this degree here was 240 degrees, and then you could convert it if you got totally lost. But I'm hoping eventually you guys will be able to kind of think your way through what is the numerator when you're coming up with these degrees in radians, okay? So I'll save this very last section down here for in class, and then we'll do a lot more practice in class too to make sure you guys are comfortable with this, okay? Thank you for watching. Have a great night. I'll see you tomorrow.